the next round, second round of the RIPE Atlas Hackathon 2015 first edition. The next team will be the disco team, and well, there's nothing more to say than disco, disco, party, party.
Yeah, we got the appetite for disconnection. Our project is aimed at the consumers, so not the network operators or all the high-level network guys. Basically, the question, is it just me who doesn't have internet right now? Our project goal show a real-time heat map of probes for consumers, probes going offline. Enrich this data with other data sources like, for example, Twitter, the Weather API, or other sources. And of course, we want a world domination like everyone. How do we want to do it? We want to combine the REST Atlas API for historical data and combine it with the live streaming API and consume third-party APIs and draw it on a leaflet map. This was our initial plan, Friday afternoon. And this was the wireframe, was made up by the designer on Saturday. Our initial approach, get the Trello board up, get GitHub up, get 2 instances in AWS, one for web, one for Elasticsearch as primary data source, and get the skeleton walking. Of course, PHP, and you should have at least one animated GIF in your presentation or a kitten will die. The moment of panic, how to get useful data out of Twitter, thanks to the jury, she freaked us out. How to handle a timeline, how to show what, everything, and wow, what should we do, was about yesterday afternoon, but we got back on track again. And always the exciting part, live demo.
So, this is the, I guess so. Push the panic button. So yesterday there was, on Friday, there was a power outage in Amsterdam. So it was a huge power outage affecting a large area. So we thought that was a nice way to show our application. So we used the streaming API history modules so we can replay the data that happened yesterday on Friday, and so we can show it on our map. So this is not the live version but the historic version. So you can see actually the nodes going down in Amsterdam. They're shown on heat map. Also from that time we have keywords from Twitter, so you can kind of know what's going on in that area. And also the weather. The idea behind the map is to actually provide more info about the outage itself. So you can find a huge red spot on the map. That means that some nodes went down. And then when you zoom in to the map, you can actually see or try to figure out why that happened. So we have the Twitter info and the weather in the area to kind of tell you why the power outage occurred. Was it maybe huge wind speeds? It could be like some polls went down or Twitter. So it basically updates live. So I'll go on a live map now.
And what I've just done, I explained my wife how to pull the plug out of my Atlas probe at home. If she hasn't read it yet, but there should be a dot popping up right now, or if she can find the USB plug into it.
It's the right one, you mean?
She asked for the USB one, so.
So basically, when you move the map, you actually see all the other nodes that
All
went.
your other wives.
Wrong wife.
Also, you see the stuff on the right hand updating based on the country or the geolocation of the map.
So you can see the weather currently here, and
the trending
keywords. Yeah. The a bit lighter version of the dots that's the plugs those are the nodes that went down a couple of minutes ago, 15 minutes ago, for example. Nodes that went down 30 minutes ago are still shown on the map. Yeah.
So the heat is basically the delay, like the time they've been offline, so they gradually disappear from the
So
map.
it's a cool off, basically.
Yeah, exactly.
Yeah.
So it starts at a red and then cools off over time.
So how did we do it? we're consuming the streaming API through a WebSocket, enrich it with the REST API from RIPE for historical data. We use Bootstrap JavaScript, Python for harvesting all Twitter trending topics, Node.js, Elasticsearch as data storage, and everything is provisioned by Ansible, so it should be easy to continue to work on it. Code is on GitHub, Elasticsearch, Docker images on GitHub, whatever. The future work, what we want to do, mobile app, because if your connection dies, you might want to check it on your mobile phone.
You probably won't have a computer.
This is already responsive. The Twitter trending, harvesting, the algorithm should greatly improve. Draw trending topics onto the map was our idea, but not enough time. Damn hackathons. Make the news really regional. Now it's just for the Netherlands. And show disconnects by ISP. That might be useful as well. So this concluded.
Let's see your,
This
if your wife plugged out the...
Yeah, my wife is plugged in. Should I return it? Let's see if it has shown up. I'm not sure. No, not yet. Whatever.
Maybe it shows up by the end, yeah.
We'll leave it running. Maybe it will pop up.
Thank you.
So this is it.
So how easy is it in the input to give it a particular country or a particular ASN to just look at that view?
Yeah, we got now go to my location.
Okay.
So if you go somewhere here and you hit this one, it sends us out back to where you are. And our idea was also to have a box to enter an IP address or an ASN and zoom into it. But like I said, it is really for consumers. What?
Your computer froze.
Oh, don't worry.
One other thing that might be interesting, we oftentimes see end users sharing sort of a snapshot of something like this.
Okay.
And so some ability to sort of click and create a permalink to a snapshot at that moment in time to say, look,
Yeah.
I was down, and they emailed a link to someone, or they posted it in a web form, or they tweet it.
Yeah, that would be a good idea. And also to have an interactive timeline would be great, so that
Yeah.
you're able to scroll back in time
Yeah.
to replay
That give us
events.
presents, and we wanted to make a timeline. It's possible with the RIPE data, but it's hard to do it with Twitter and Twitter because they don't really store historical data.
Yeah.
So we have to store them on our own, and that's a lot of data
Or
for
they
a little
can
bit.
borrow access to the data.
Yeah.
It's not that they don't store it, I think.
Yeah, they don't allow.
So, how easy was it to get the Twitter data out in the end? Was
In this way, very easy because it is not really smart now.
Okay.
We just started trending topics.
Uh-huh.
One of the ideas we'll have is to have a keyword list for big major events,
Okay.
and if they match, then enlarge them or
Okay.
make them red or
Can
whatever.
we have a look at the keywords that you got out from the from during the storing during the delay during the outage?
Well, that's just
It looks like-
that's
it looks
sort
like
of
you've got
mockup. That's
Because they look quite relevant.
Yeah.
Pretty good.
Just load the demo page.
Slash
Yeah.
demo. Yeah.
So who owns the domain? Anna-Kaisa, I don't know.
No
Open it.
questions from the audience.
Refresh.
Okay.
There we are.
Right.
Power outage, disruption,
but
traffic,
that's just
train traffic, cause, flight schedule, short circuit. That
And
are the
demon.
trending topics.
It's not
Demon,
a,
yeah.
it's not a demon. It's a it's a
No.
name of
No.
the city.
Demon was where the problem happened.
Yeah.
Yeah.
Ah.
In English, it's like a city. Okay, so you pulled those from a retrospective Twitter search, did you?
Yeah,
Right.
that is where the Python came in, right?
Well,
Python
this
hard
is sort
to
of manually made list though. I mean, that's just
Yeah.
for the demo, so it's
Yeah,
not
yeah,
using
yeah.
anything. I mean,
course.
we have
Yeah.
the tweets from the event during the event, so
yeah. I mean, I think it works really nicely when you've got like a nice use case, but I'm a little bit doubtful as to how this is going to work in real time. But I mean, for now, that's actually pretty good.
I
This
think
is
the
the-
event needs to be pretty big, right? That's
Sorry?
that is something like this. I mean,
Exactly.
it won't show up
Yes.
for a.
And this is the
Yeah,
speed
that's
up
the problem.
delays, the
Yeah.
decay. So it usually takes half an hour, and we speed it up for a demo to a minute, so you can see how the large hotspots of the problem actually stay longer on the map.
Nice.
So our guys back in the office, anyway, upstairs, downstairs, they are actually preparing a labs article about the event. So I would love to include a permalink, something like what Jason said, but that says show me from time X to Y. If this URL is shared, it will just show you the thing.
Yeah, should be possible.
That would be awesome.
Yeah.
Thank you.
Okay, cool, awesome. Well, as soon as we can predict the weather based on Atlas, we are there. So the next one is Jelle, and he's going to present or basically compare BGP data with active measurement data from Atlas.
Okay, so the idea behind this hack is to look at 3 different graphs that you have in network land. So on the most left-hand side, you have the sort of the connectivity between autonomous systems. So one autonomous system has a bunch of neighbors. This graph exists somewhere on the planet, but I cannot really geolocate autonomous system or anything like this. But in principle, this is sort of the biggest graph of all possible routes through the network. Inside that graph is a more specific one, which is for a given prefix, which, there should be 2 edges here, but which paths go to that autonomous system. And then there's an actual traceroute with between nodes. So it sits on top of these, and I somehow wanted to combine these 3 graphs. And of course, they somehow fit on the Earth, and that works in geolocations and not in IP addresses or autonomous systems. So what's the relationship between these graphs? Well, an autonomous system is responsible for a number of IP blocks, and within each IP block you have possible IPs or nodes, and they might or might not be geolocated on the Earth. So, yeah, what this tool does, maybe I realize now maybe this is a bit too abstract, but in any case, let me show you the tool first. Oh, nice idea. So, when you start it up, this is showing you all the anchors, obviously, that are running for Atlas. Oh. So if I would click on one of these anchors, I can look up in which prefix does it fall. Then I can look up which autonomous system is responsible for this. Then I look up all the paths, all the routes that it gives. And then I get, for each autonomous system at the end, I look for all whether there are probes available or not. And it's also important that I have the route collector, the RIPE Atlas route collector, pulling in all the BGP data from this autonomous system, so that I can do the same thing the other way. So I can say, from this system, give me the routes back to, the paths back to the AS1. So let's do that. So I click on a node. You see the IP address and the IPv6, and now it's script running. See it going la 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 la. Okay, so here you see all the, well, not all, but these are all probes that can reach this autonomous system I clicked on. They're colored by the autonomous system responsible for this probe. So here you see very clearly that this blue guy, I cannot really geolocate it at all. It's all over the place. If you would now click on this, and if I would have gotten it to work, what would have happened? So the first thing I do, I schedule. So this is one of the other anchors from here, the ones which I can schedule traceroute back. So I start doing the traceroute. And I start getting these nodes, for instance, it takes these paths. For each node, I can look up which autonomous system is responsible for it. And that way I can take the traceroute and put it on top of the BGP paths. Then the next step is to go back and geolocate these guys back on your map. And if these two nodes were involved in the traceroute, you put a bounding box on it. And this would kind of be the graph between. There could be another path here, you know. But so this is like the BGP route, and this is the trace routes inside of it. But I barely got it to work, but not exactly. So the dots you see here are D3 rendered dots, and I was thinking of putting Valentino's force-directed layout thing on top of it, but I didn't have enough time. But that way you could say like, okay, between here and here, I maybe find a path like this. Well, there are other nodes in here, of course, that are not probes. Suppose there's one here, you go like this. But maybe there are nodes in between here for which I cannot find a geolocation. So you would pin these two and then do a layout like that. So you can kind of show the BGP flows and see if they're actually, there's a lot of metadata that's I suppose interesting to see if they're actually routed according to the best path or not. Yeah, that's roughly the idea. Questions? I forgot to say, of course, the code is on GitHub here. Yeah.
Can you scroll back up to the name for me? Thank you.
And so to show you that I almost got it to work, that I'm not bullshitting at it. So I just couldn't somehow get this to render. But okay, yeah. So questions?
Where'd you get the anchor?
It's an icon that I was looking for an anchor icon. I also found some possible probe icons, but I thought that I thought P it's for parking, but that's probes were looking like this.
Well, one comment is that I really wish you could finish.
Me too. I'm like pretty close.
Yeah. This is one of the most difficult things, mapping BGP with traceroute, and not even talking about geography. Those two are already very, very difficult in themselves. So
yeah,
you chose something very difficult, which I really appreciate.
Well, yeah, I think it's actually very doable from this point on.
Yeah.
I mean,
it's I suspect that the devil is in the details. So getting to 90% is possible, and then
that's maybe something I should say. So you're seeing now a lot of probes, but that's because it's not completely filtering properly. But you'll see less if you restrict to the probes for which you have the full pairing. And then I can also decide to drop all traceouts that have stars in it and so on. So
you can simplify. Yeah, you can simplify.
I just throw away the garbage data.
You have to do that because we have data that has garbage in
it
by the nature.
No, of course.
Too much data.
Yeah.
Can I just ask, how closely did you work with Valentino? Because I see a lot of things which I miss in Valentino's presentation and vice versa in both of what you've done.
Well, this morning I went to him and we tried to see like if this was possible, and I started doing it, but I somehow couldn't get D3 to. Yeah. So his code is actually in the repository, but couldn't get it to work. Also, might be a bit of overkill, but.
Okay.
I see a lot of potential, and I know that a lot of operators would like to use this tool when it is more developed and when it is a bit more focused. And I see a lot of potential for combining it with different projects that are already going on, that were written by other people.
Yes. And so CJD's multi-point traceroute thing, it's also using D3. You could, for the nodes that you have geolocations, pin them on the map and have to do the rest of the layout. And then
There is
just
open IP
bounding
map.
boxes on top of it.
Yeah, and there is some kind of router, some project from Russia that is also trying to play with BGP and Traceroute at the same time. And then there's
Yeah. So I made a list of the APIs that I use actually. So Open IP Map is one in there. So yeah, it was really nice. Almost everything is in there that I need. So it's like stats, BGP, state, the data API. Yeah. But yeah, so pull request, welcome.
thank you.
Thank you.
Cool. Thanks.
Cool.
Thanks. That's all right.
Okay, the next presentation is less visual but more DNS. It is Matt and Rufi. Please come and join me here. It's very cozy with all the jewelry here.
Okay. Yeah, I'm Matt and work with Ruwaifa on this project. We're calling it Zeerover DNS. So why do we want to do this? So what we've learned is RIPE Atlas is really targeted at network operators, and so the idea is that they would like lots of vantage points on the internet to measure towards a lot of the infrastructure that they own. So these types of measurements are, it could be a bit fewer and longer running and probably repeating over time, for monitoring and purposes like this. So me and Ruwaifa are graduate students working in internet research, and so when we found out about this, we wanted to take what we normally do for internet research, which is basically, we want to measure the entire internet from all the places we can, and so this involves probing lots of destinations, and so the main problem with this is that creating a lot of these measurements at one time for one-off measurement studies for research papers and things creates a heavy load on the system. So we need a better way to deal with this. So we had some discussions with Emil and Vesna about when we were talking about how we could, how we could better plan our experiments. And so the idea came up that we could use DNS to specify multi-destination measurements. And so the main idea is that a user would input the destinations that they're interested in measuring to some sort of service. This service would give them back a unique host name, and then the user would then create their measurement in the normal fashion through programmatically or through the web interface using this host name that the service has generated. And then the authoritative DNS for that host name would resolve the different destinations over time as the probes went along and their regular scheduled measurements. So we created the Zeerover DNS service, and so we've got this currently on GitHub now. So this basically is just composed of a simple web front end. We stood it up with Apache and PHP. It's backed by a MySQL database. And the DNS implementation, we actually extended an existing DNS server that Emil had pointed us to a little while ago called the Ninja DNS server. And so we decided to stick with this sort of nefarious career choice theme. And so Zeerover is Dutch for pirate. And I thought it sounded cool. So that's why we called it this. And some of the other stuff we used in our DNS server, we use some SQL alchemy, so you can, we have, the DNS server doesn't have to hit the database so much, and you can swap out whatever database you want. And then we use some application caching to further, improve the resolver latency. And this is basically the idea for how this behaves. So going down, you've got time. And the user has 3 IPs that they've submitted to a service. And they, this basically just shows that every time the probes repeat their measurement interval with this randomly generated host name, they're going to get back, first they get back IP A, IP B, IP C. We're using a very low DNS TTL to do this. Our current issue is that we're at the mercy of well-behaved LDNS servers. Most on the internet are, but that's one issue. But we are exploring several ideas to get around possible caching issues. I have basically a quick look. We don't have much time at what the service looks like, but this is basically our simple service. We've got a host name and some IPs. We've got a measurement interval of 5 minutes, and we submit this. And this is the randomly generated host name. So basically, you would grab this, and then go to, schedule your measurement as you normally would through the web interface. Yep, and then you just pop it in and fill in the form as you normally would. And that's about it. Questions?
What does the output look like?
From the measurements.
Yeah.
The measurements.
Standard.
Yeah, it's exactly the same. So the probes just behave as normal, but what is going to be different is for a given probe, in the measurement metadata, you'll see different destination IPs, but the destination name will be the same.
I'm not sure if you said it. How many IPs can you put in behind one name?
I think right now we didn't have a limit. Probably right now it's just limited to the size of the text field in our database. So yeah, I haven't done the math, but yeah, we probably have to sit down and consider what a reasonable amount would be. But yeah, in theory, I don't think there's any real restriction.
B4 or B6. Yesterday evening we had a chat about it, and with some IPAs, so I guess that's where IPA comes from. Could you do campaigns like, for these 10 minutes the host name is this IP, for the next 10 minutes the host name is that IP, and then for the next 10 minutes after that, versus pick a random IP?
So actually it is that how you just said is actually how it currently works right now.
Which one?
That it for a block of time it gives out one IP, and the reason it does this is because if we are doing any round robining, we can't be sure, because all we can see from the DNS resolution side is the probe's local DNS resolver, and if we give out random IPs, we have no way of bookkeeping to see which probes have been able to measure what IP addresses.
Until you get the results.
Until we get the results. So there
you can tune into the stream.
Yeah, Yeah. So there's a couple things about eDNS, using eDNS that we could use to get around this stuff, or the probes could do local or direct resolution as another approach. Yeah.
Okay, cool. Thank you. So, all right, we have 2 more presentations to go, and the next one is BAM or BAM or BAM or whatever. BAM, yeah, of course.
Oh. You are pretty aggressive.
Okay, so what we did, it's something we call BAM. It's a BGP Atlas monitor. You can get it on GitHub. Our first goal was to aggregate useful BGP information from RIPE Atlas and RIPE Stats. And the goal was to provide a tool to network operators in order for them to monitor their prefixes. And the ultimate goal was also to try to use a new BGP streaming API in order to update the tool. But we didn't succeed to do that. So there is a tool, a website. Here on GitHub we put some screenshots. We'll do a live demo. You can try it yourself. So what we did a virtual machine with Vagrant. So you can just clone the GitHub repository and then do Vagrant up, launch these commands, launch BAM, and then you can connect to the website. So there is nothing to do on your side, just clone and let Vagrant do its magic part. Also, you can find some command line tools. It's not only the website. So you can do some stuff like get a list of prefixes from your autonomous system, your ISN visibility, and so on. Everything is implemented in the website. Can you give me a share? Okay, let's try. Okay, so for example, I can use a tool like that to get the probes, all of the probes in one autonomous system. Could be useful for debugging, for example, if you know that some prefix is not reachable, you can launch that, have a table, get the name of the probe in a specific prefix, and then launch measurements. And so you have what? Visibility also. Oops. So it will give you the visibility of your autonomous system as seen from risk collectors. So you have the collectors here, your visibility for IPv4 prefixes and for IPv6. So for this autonomous system, we can see that some of its prefixes are not reachable from the collectors in Amsterdam and London. Do you want to do the demo?
Yes. So, and for not the CLI guys, we also have...
Please speak up for the people.
Okay, also for the not CLI guys, we have done a web service, our BAM page. So just roll it back from the backside. So if you're an operator, you're always interested if your prefixes are distributed or your prefixes are all over the world seen the same. So, and at the moment it's just random data. So because normally you see on every route collector sees every route, so everything would be green. So just for the demo we just added some random data. So you see the top prefix here has a problem, is not seen on the whole collector, and all of the others. You can, yeah, and it's updating with live data. It takes a little bit, and it's always querying the API from RIPE. You can even do here some magic and see if you're especially interested in some prefixes. Then the same for IPv6. And then represented on the map. So you can see if some prefixes have a problem. That's the collectors and the risk collectors. And the colors shows if it has a problem there. So for your NOC, just plan this map there and you see if there's a problem with your prefixes somewhere in the world. So that's the main idea, to have a beautiful map just for NOC. So you can say something for the props?
So props maps, it's not over yet. So the goal, it's time to refresh.
You have to reload it. Yeah, refresh them.
So the main goal for the probes map was to show an operator if he has some probe in his own network, where they are. We didn't finish the work, but the idea was to click on a probe, get its, for example, its ID, the IP addresses, and for example launch a traceroute in order to debug. So it's random data, but our goal was to change the visualization to reflect, for example, packet loss or delay, in order to show operators where the problem is, and maybe they need here that's close to Bordeaux, that's a French city, so maybe if it's red here, there is some stuff going on the DSL part of the network, so they can debug by clicking on that and launching traceroutes. Also, Thomas worked on something using the streaming API in order to get results from the built-in measurements, and the ID, and we didn't succeed to do that, was to display the change in TTL and delays if there is a network issue. So the idea was to, for example, you have red, you click, and then you get the feed from your probe in order to see if the delay increased or not. But yeah, it's not working yet. And ultimately, you want to plug that with the BGP streaming API in order to reflect the change of prefix visibility directly in the app.
And one last topic from my side. The ultimate goal of the even here on the collector, it should show you if some of your prefixes get hijacked somewhere in the world. So we map it against the
BGP streaming?
Yeah, the hijacking.
Oh yeah, yeah.
Yep. Can you explain a bit?
Oh yeah. So yeah. Okay. So the idea was to check if one collector, for example, here in Japan, is seeing your prefix announced by someone else. That's why we want to plug that with the streaming API. But we have some POC, but it's not on the GitHub yet, and it's not ready to be used.
So this is all on GitHub. You can use now.
And the tool also is really easy to use. So if you want to try with another network.
3333.
Which one is that?
33. RIPE NCC.
Like that?
Yeah.
Is it big? Could you slow if it's big?
No. Should be very big. But we have NCC.
Okay, it's refreshing. I'm using the real data. I removed the minus random flag. Yeah, the wireless network is a bit slow. So here you will see 3333 anytime. So
wireless was. Give it a turn. Oh, no.
Oh yeah, you have probes.
Oh, we do.
And they are up.
And on the collector side,
yeah, everything is okay.
Thank God.
You're safe. Okay, that's quite convenient. Convenient tool for operators. And that's it. You want to say something?
No, it's okay.
Thank you.
Oh, we didn't mention we had a fifth in our team. She did the logo.
Nice. And the colors.
And colors.
Which is really important.
Yeah, thank you.
Thank you. Questions?
I want to know about. You said that you were using fake data for one of your mock-ups, one of your screens.
Yeah.
How close is that going to be to the kind of real data that you might get? Because when you actually do the real test, and I see everything is working normally, everything's working perfectly fine. So what I want to know is basically in that visualization, how often is it going to look like that? And have you really considered what it's going to look like with the kind of data that you would expect to get?
So this one, for example.
I was thinking about the big grid thing where you've got all of the performance.
No, this is a good example because some IPv prefixes are not reachable. So we'll see that on the map. So that's the probes up, and here you can see that on the collector map some prefixes are not reachable.
Okay.
And here on the V6, so we need to wait a little bit. That's a V6 prefix, I guess.
Yes, it's a V6.
So you need to wait for the data. Yeah. So here you can see it's the same.
Yeah. Okay. So that's so normally you would have to be really looking for a very very tiny variance, or would it often look like the thing that you showed earlier, where you've got?
No, it's always like that usually.
Really?
Yeah.
Okay. So for the ideal case, you would see this, but if something's going wrong, then
You know that you just need to check the collector map. See that, for example, that's a collector. That's collector 0.
Yeah.
So you can it's moving. So you can just select and sort using this stuff. So in this case, there is only one prefix, but for example, you can sort the value in the wrong ones and put the wrong ones on top.
Okay. Right. Now I'm just sort of interested in the quality of your dummy data as opposed to the data that you would
It's purely random.
expect to see.
The goal of the dummy data was just to make the JavaScript work in order to check our code.
Okay.
And even to see if it's updating, because it's real time, it's updating all the time in the backend, so it will change. So we even can just reset the server process and bring other data in and then to.
The reason I mention this is because it's always best to mock up with real data if you can, because when you mock up with randomized data, you don't actually get to see what the data is really likely to do. So essentially, you can't really design with randomized data in as much because it's not showing you the things that you would normally see. So if you're kind of looking for patterns, then it's always best to actually mock up with something which is real.
The goal of the random data was just to play with interface, not to actually.
Yeah. That's what I'm saying. If you're playing with the interface, you really, really
the interaction.
Yeah.
That's why we don't need real data to do that.
That's the thing.
In our case, it was just to test the front end.
Yeah. Well, that's what I'm saying is that when you're designing that front end, you do need to be able to see the real data, because basically what you're showing me here is that what I'm seeing with real data is very different from what I see with random data, and it's actually much harder to see what's going on because the changes are so different. You're looking at much smaller changes. So I'm just kind of arguing slightly with the methodology of using dummy data there, because it's kind of difficult to prove cases there.
Okay. But again, it was just to take the technical side.
Yeah. I know how this works because I've been through this problem myself, and this is why I'm raising it. Is because I recognise this problem of basically the difference between random data and actual data and the design challenges that presents. So that's something which I think you really need to be aware of moving forward. Is basically it's good to actually get something working and you've got working code and that's fantastic, but the next stage is basically to sanity check that with what actual data actually looks like.
Okay, so that's it.
Which is that.
Yeah.
Yes.
And live data, of course.
Yeah.
One more thing to keep in mind: if your ultimate goal is to make this appear on a network operator center screen on a wall, and stuff happens, and then stuff just disappears from the screen because now something else happens, that will lead to people looking up and say, oh shit, what was that? I don't know, it's gone. So you have to find a means of making it stick somehow. The important events must be recognizable. They should not be transient, because otherwise you get frustrated NOC operators saying, what was that? I don't know. Do we have a problem? And let's dig in.
Okay. But it's kind of stable anyway.
Hopefully.
Because the data source is updated every 8 hours, so even though we are probing really fast, it's really stable. So unless you go to the bathroom at the wrong time, that's okay. During 8 hours, so it could
every 8 hours you can.
All right.
Thank you.
Thank you. Okay, last but not least, we have a presentation from our next editor, which is Wim. No, of course, Wim. Okay, not a lot of people got that joke. It's alright, it's late. And Vin will talk about probe streams, right?
Figure out how to connect this.
Yeah. I think you need to change the adapter for that. Are we gonna take care of
Okay.
this?
In the meantime, I'm going to announce that very soon we will all have to leave. Due to security, of course, and the party is waiting for us. So the one after this is bottle, so drinks and some snacks, finger food in Tara. So there will be 4 people walking with you to Tara, which is 10 minutes walk from here, and those people are Dan, Christian, and Christopher, and Kave. Well, Kave will make sure that you are all out of here in time before the security comes, and then he might or might not walk with you. And then there are some Amsterdammers who also know where Tara is, so we will not lose any of you.
Okay, just quickly. I mean, this is a well, we can choose. Either you have a adapter with HDMI, or we're gonna stress your imagination in a way, and it will be a presentation without slides. Does anyone have a HDMI adapter?
I have something to HDMI,
yes,
not something from HDMI. We need an HDMI to some analog.
Last call.
I don't know if
that
exists.
Do we have a USB stick? We can put it on a USB stick and hook it on your computer. Well, is it online?
It's not online, but it's okay. I'll probably.
You need just a web page.
You can show your screen to the camera, and we can project this guy over there.
Okay, come all in the front.
No.
Okay, let's try that.
No, seriously. Seriously. Yep. Show. Plug it in here. Give me the monitor.
That's what he said.
Yes, but give me. I need that too.
I don't know what's happening.
If this works, this is going to be a real hackathon.
Yeah.
An absolute hack.
I'm not sure about the interfaces you need, but I have this about